Hey, how's it going, everybody? Today we're going to have a look at another coding question, and it is the valid anagram question, which is Leetcode question number 242, and it's in the section Easy. The question goes as follows. Given two strings s and t, return true if t is an anagram of s and false otherwise. Now, that is a lot to chew on, so let's have a look at an example over here on the right-hand side in the Paint window. So let's have a string called s, and it is the word anagram. And now we're meant to return true if t, the string t on the right-hand side over here, is an anagram of the string on the left-hand side. And what exactly is an anagram? An anagram is a word that we can make using the same letters from another word. So in this case, you can see that we have 1, 2, 3 A's. We also have 3 A's over here. Then we have one N, we have a G, an R, an M, an M. So we have exactly the same letters in the string S as we do in the string T. And that means that T is an anagram of S. Now, if we were to have, let's say, two different strings, let's say our string S was the string B, A, D, and the string T was simply S, A, D, then T would not be an anagram, of the string S, because, of course, we have AD in both of these words, but we do not have the letter S in our first word. Instead, we have the letter B. So in this case, we can't say that T is an anagram of S. But let's go back to our original example, and let's think about how we can create an algorithm to check if the string T is an anagram, of the string S. So the first thing that we can do is we can already check if the number of letters that we have in both strings is the same, because we can only create an anagram. So more specifically, T will only be an anagram of S if the number of letters is the same. If T has more letters, then it isn't an anagram, and if it has less letters, then it cannot be an anagram. So that is the first thing we're going to do, is we're going to check if the number of letters is identical. So this is the first thing we're going to do. And then the second thing we're going to do is, if the number of letters is in fact identical, then we want to count the individual numbers of letters in each of the two strings and compare them. So count letters and compare. And that is exactly what we're going to do over here on the left-hand side in our editor. So first of all, we're going to define an algorithm, as we always do. And we're going to pass in as arguments two strings, S and T. Next thing we're going to do is we're going to create two dictionaries. So the first one is going to be called S string. And there's going to be a second dictionary called T string. And we're going to make both of them be empty. So this is the first one, this is the second one. The next thing we're going to do is we're going to do what we did in step 1 over here. We're going to check if the number of letters is the same in both strings. So we're going to say that if the length of S is equal to the length of T, then we want to continue with step number 2, which we're going to get to in a second. But if that isn't the case, if the number of letters is not the same, then we can write an else statement over here, because then we just want to return false. because if the number of letters is not the same in both strings, we can automatically say that we do not have an anagram over here. Now we're going to move on to step 2, which is counting the letters and comparing between the strings. So we can do that by doing the following. We're going to take a for loop, and for each letter in the string s, and notice here that I'm putting s into a set because that means we can loop through it. And we're going to say that s underscore string, which is the dictionary we defined. And for the letter that we're iterating through, we're going to set s.count. We're going to count the number of occurrences of the specific letter that we're iterating through. So in this dictionary s string which we're creating over here, the letter is the key and the number of occurrences of the letter is the value. So we have this key value pair in this dictionary. Now we don't only need to do this for the string s, we also need to go ahead and do the same thing for the other strings. So for letter in set t, we're going to do exactly the same thing. So t underscore string letter is equal to t dot count letter. All right. So now that we have these two dictionaries over here filled with the letters and their occurrences, you know what? Perhaps let's have a look at what this looks like if we go ahead and execute this once in our terminal over here. So let's go ahead and print out the s underscore string, and let's go ahead and print out t underscore string, just to see what it looks like. I think it gives us a little bit of a better feeling for what's happening over here if we visualize this. So let's go ahead and print out algorithm, and then let's put two strings as arguments into this algorithm. We're going to take exactly the same example that we have in the example over here, so anagram and nagaram. And let's go and execute this. So what's happened over here? Let's have a look at what happened in the terminal. As you can see, our for loops have run. This is the for loop for the word anagram. And then we also have the for loop for the other string, which is nagaram. And you can see that we have this dictionary and it's filled with the key value pairs, where the key is the letter and the value is the number of occurrences in each of these words. Let's perhaps take a bit of a simpler example. You remember the one we had earlier with sad, and let's take bad. So now you can see that we have sad over here. So you can see we have one S, one A, and one D. And similarly, we have bad with one B, one A, and one D over here at the bottom. So you can see that we're breaking up the words into these dictionaries, which we can now proceed to compare. So in the next step, we want to compare if the occurrences of each individual letter is equal in each of these strings. So for letter in s underscore string, we want to check if s underscore string letter is not equal to t underscore string dot get the letter. And now, if the number of occurrences is not equal, we can go ahead and return false. Now, similarly, what we could have said is we could have simply said if they are equal, we can return true. So this would give us the same result in the end, but we're just saying that if the number of occurrences of the individual letters in the string S is not equal to the number of occurrences of each letter in the string T, then we want to return false, because in that case, the string T is not an anagram of the string S. However, if this if statement isn't triggered, then of course we are going to need to account for the case that the individual that T is in fact an anagram of S, in which case we can simply return true. So now let's go ahead and run this one time. Let's take our example from earlier with anagram and nagaram. And before I run this, let's think about what we would expect to happen now. What we expect is that first, our algorithm is going to start and check whether the number of letters in each of these two words that we're passing in as arguments down here is the same. And of course, we know that the number of letters in anagram and nagaram is in fact the same. So we're going to go into this if statement. Then we're going to build these two dictionaries that we printed out earlier with the individual key value pairs of letters and count of letters. And then we're comparing the two strings to see, we're comparing the two dictionaries, of course, to see whether or not the contents of the dictionaries are the same. And if they're not the same, we're returning false. And if they are the same, we are returning true. So I think this should work. And yes, it does. So in this case, a nagaram is an anagram of the word anagram. So we're returning true. But let's take another word, for example, bad and mad. And in this case, you'll see that we're getting false because the word mad is not an anagram of bad. But then again, if we add the B to this second string, then the letters in each string are going to be identical again. And we're getting the output true because ADB is an anagram of the letter bad. And as a final example, if we were to have the same string and we add an additional string to the second string, you can see that bada over here on the right hand side is not an anagram of bad. And that is not because it doesn't have the same letters, because bad is included in both, but we have this additional letter. So in this case, we have the output false because, of course, we are checking if the number of letters is the same, and it is not the same in this case. Okay, I hope that makes sense. And we can now skip to the second solution possibility to this algorithm question. And it is in fact so simple that we can quite simply write it down because it is just one line of code over here, which we're going to be executing. But before I tell you the line of code, let me just briefly show you what we're going to do. We're simply going to sort the individual, strings which we have as inputs alphabetically, and we're going to check if they are equal to one another. So the way we can do that in Python is simply returning sorted S and checking if it is equal to sorted T. And let's take the example that we had at the very beginning with anagram and nagaram. And if we execute this, you can see it returns true because, of course, it's just comparing the sorted strings. So it's sorting S alphabetically and T alphabetically and checking if it's identical. And of course, if we were to take out a letter, then of course, this second string is not an anagram anymore, in which case we're getting false. So Here we go. We have one complicated solution and one very simple solution to this algorithm question. I hope you enjoyed this. If it helped you out and if it helped you prepare for your next interview, then make sure to give this video a like and yeah, see you in the next one.